I'm Litsa Michaloudi, and as Thanasis said, I come from the laboratory of ichthyology. And I'm going to step up a little bit in the food web and take it to zooplankton. We all know that zooplankton is a very important component of the aquatic food web in general, as well as supporting fisheries by being consumed by fish as food. And as such, it is used in models where we, as Thanasis said, we need real actual data. Just, I tried, this is a painting from Gligoric. I saw a couple of paintings in previous presentations. I just want to say that I tried, like Thanasis, to make an AI food web of a painting of the food web, but apparently the free AI isn't aware of what a copyboat is. So it did came out all wrong. Anyhow, here I'm going to talk about the situation about zooplankton studies, marine zooplankton studies in the Hellenic Seas. And let's say that studies started something around the 1970s, and as we can see, they are characterized by spatial heterogeneity, referring to the areas that are most well studied. The Saronikos Gulf and the Cretan Seas, as we can see here in the map, are the most studied areas, and these are shown here in the tree map as well, where in the upper right corner, the number of studies published for these areas can be shown. This variation is also recorded in relation to the sampling frequency these data have. So most of the data that are being published are limited in time, and they cover mainly the summer period or the warm period, while very few studies cover longer than 1 year period. In order to understand whether these are few or much studies, we have to take into account that there are a lot of cases in these numbers where the same data set has been used for different publications, and we are talking about only published data. So there are a lot of, I'm not sure, but there are data available sitting in gray literature. And as I know, there are many, many samples that are being collected by projects Manos Koutrakis presented yesterday, where the samples are being collected and they are being analyzed for ichthyoplankton, but nobody is studying zooplankton. So there are a lot of data and samples that we know nothing about. What we can conclude is that there is no zooplankton monitoring happening in the marine Hellenic Seas on any basis. To complicate a little bit more what we know about zooplankton, we have to talk about size fractions. So the majority of the studies are reporting metazo and mesozooplankton being collected with a 200 micrometer net, while only recently the metazo and microzooplankton is being acknowledged, collected with a 50 micrometer net. And I am emphasizing on the term metazoan microzooplankton because traditionally in the literature, we are used to hear about microzooplankton, which refers to the unicellular heterotrophs of the food web. So what has been established from studying the metazoan microzooplankton is that this size fraction is immensely underestimated, leading to erroneous estimates of biomass and secondary production, and there have been cases reported, published cases, where metazoan microzooplankton numbers are even more than 20 times higher than mesozooplankton. Here are two examples of our studies in the Thermaikos Gulf on a spatial basis, where we can see the microzooplankton abundance compared to the mesozooplankton abundance, and a similar study in the harbor of Kavala, where we can see the maximum numbers of mesozooplankton collected with 200 micrometers nets compared to the metazone microzooplankton collected with the 50 micrometer nets. So metazone microzooplankton is actually dominating, and within this size fraction, the dominating parts are the developmental stages of copepods, as we can see here in the example of Thessaloniki Bay, where NAFPLI, the first developmental stages of copepods, make up to 89% of this community, followed by the small-sized taxonomic class of Cyclopoida. So this community of metazone microzooplankton did hide some more secrets when we were studying Thessaloniki Bay, as the tracking of non-indigenous species. Out of the 42 non-indigenous planktonic copepods that have been recorded in the Mediterranean, 5 have been recorded in the Greek Aegean Sea, and 2 out of them have been recorded in Thessaloniki Bay and the Kavala Harbor. We're talking about the calanoid Pseudodiaptomus marinus, which is spreading rapidly in European and neighboring waters, increasing its records more than 400% during the last year, and the invasive Cyclopoid Oithona davisae, which is a highly invasive species, occupying new environments all over the world, including the Black Sea, the Sea of Marmara, and other areas in the Mediterranean. So another secret that we revealed in the metazone microzooplankton community was the fact that we have rotifers. We have collected and studied the populations of rotifers that are traditionally being considered to inhabit freshwater habitats. And despite the fact that 200 species are exclusively marine species, but we can understand that due to the smaller size fraction being lost when studying traditionally the mesozooplankton community, these creatures are being lost. So this metazone microzooplankton community does have implications in the way the food web is functioning. So this is the examples I'm showing is from a PhD in the Thessaloniki Bay, where during the study, haptophytes and diatoms were the blooming autotrophs in Thessaloniki Bay, which is, I have to mention, it is a very anthropogenically stressed environment where many blooming phenomena are occurring constantly. So trying to find the relations between the heterotrophs and the autotrophs, having in mind that what we all expect from a food web that zooplankton is consuming phytoplankton, we found that the dominating parts of the heterotroph, NAFPLI and Cyclopoida, have no negative connections with the blooming parts of the autotrophs, while there was an actual cascade, trophic cascade, beginning from cyclopoids all down to HNF and pico phytoplankton, indicating that there is a rather strong connection of the classical food web with the microbial loop. And this means that the small size of the dominating zooplankton community is inadequate in grazing the phytoplankton like diatoms. This is an example of size, and we can really understand why. And at the same time, the fact that small Cyclopoida are dominating and leading this trophic cascade down the microbial loop, we show what we find in literature, that these species have a preference for more motile taxa, like ciliates, against phytoplankton. And if we take into, and we have to add up here that Oithona davisae that is gaining ground in the Thessaloniki Bay does not actually like to consume diatoms. So putting all that together, we see that we have a loose predator-prey relationship that leads to loopholes in this food web functioning, allowing phytoplankton to explode. And so we have a further explanation besides anthropogenic impacts and increased nutrients loads about the frequency of blooming conditions in this study area. So to wrap it up okay, we have seen what we know, what we don't know. What do we have to do? We have to, and I will start from this part, we have to analyze the existing samples. And we have to publish our data. And we need to maybe use new methods in order to speed up the bulk information that we might get out of all this existing information. And of course, we need to consider monitoring of all the components and size fractions of the food web, because only studying one part or the other part, just mesozooplankton, just phytoplankton, or just fish, we only get one part of the picture, and we never know how the whole ecosystem is actually functioning. All these are being done with help from my colleague, Professor Maria Moustaka, which is my help with lower trophic level phytoplankton, and students from the laboratory, whether they are working in freshwater zooplankton or marine zooplankton, with PhD students that have finished, Georgia, Maria, and Jenny. Most of the data that we have seen come from Jenny. Georgia Ktistaki, who is trying to make use of the available samples that are down in the institute in Crete and analyze them to get an idea of that. Christodoulos, who is just about to start his PhD, master students like Evie and many undergraduate students and many more, including Athanasia that is in here, that I didn't have pictures to put in here. So thank you very much.